Hi, welcome. Today I'm joined by James Douma in person here in Austin. We're doing a post Tesla AI Day review and reaction. This is going to be actually two parts. So, this interview will be more of a general kind of thoughts about the day, answering some questions. And then tomorrow, we're going to do more of a deep technical dive into the technicals, um, diving into each part of AI Day. So, anyways, James, I want to welcome you on the show again. It's great to see you in person.
Thanks. Likewise. Been a while.
Yeah, I love these in-person interviews. A lot more,
Yeah.
I don't know, information or
So your
dynamic.
opinion about that has shifted a little bit since the
Yeah,
first time we did it.
yeah, I definitely prefer it. So James, the last time I saw you were at AI Day. I briefly got to meet you after to get some reactions, but
hmm
how was maybe take a step back, how was your overall kind of experience at AI Day?
Wow, it was kind of overwhelming to be honest,
Yeah, it's like a
right?
Tesla event is, yeah.
It there were so many people I wanted to talk to,
Mhm.
and there was like so much stuff to absorb, and I feel like I just got sort of a taste of it. So
Yeah.
that's my first impression. The other was that they really obviously, there's only so much that you can, that they can show in an event that's only a couple hours long. But I feel like they're diving more into technical stuff. They're showing us more about what they're doing, and
Yeah.
it's nice to get a sense of sort of how they structure the program, how many people are involved,
Yeah.
how things evolve over time. And I felt like the opportunity to talk to some employees was really nice. I really enjoyed
Yeah.
that. So thanks a lot to Martin for inviting me. It was really
Yeah.
great.
Yeah, I thought that was like I mean, the presentation itself I thought was better online because the audio is
Mm.
better. Inside the auditorium is kind of hard.
Yeah. Yeah.
But the highlight was the tables and the booths
Yeah.
around the whole, seating area where you got to meet all the teams and people and see how they're kind of, yeah, how they're structuring their,
Yeah.
everything. And it was cool. It's like asking them what they're doing, what their role is, and
Yeah.
I
A
went
little
around.
show and tell.
Yeah,
They have some
yeah,
stuff on the
all the
tables.
monitors and
Yeah.
stuff. Did you meet any interesting people and interesting employees or?
Lots.
Oh,
Yeah.
really?
Everybody I talked to was really interesting and
It's cool.
fun, and I got a little bit out of them. Like I
Hmm.
said,
Yeah,
I, I, I wanted to literally talk to everybody at every booth. Like I didn't see a booth that I
yeah,
didn't want to talk to, so I just like went down to one end. And when I first got there, I went to like the robot actuators and stuff because those guys were there, and that was something I was interested in, and got a chance to chat with them for a little while. And then the presentation started. And then afterwards, I was just like, man, I've only got 2 hours. I've got to. And I started at one end of the booths, and
uh,
I got like maybe a quarter of the way through or something. I feel like
yeah,
so. I didn't even get to talk to anybody on Dojo for the most part because
yeah,
they were at the other
yeah.
end. Yeah.
Yeah. So overall, let's take a step back. What was kind of maybe your key or one of your key overall impressions, takeaway, like pre AI day and post AI day? How are you looking at Tesla's AI efforts differently?
Hmm. I would say more than differently, more like kind of a refinement. There were
Hmm.
going into AI Day, there were lots of different ways I could imagine that they were doing stuff inside, and I feel like that's kind of narrowed down. And of course, that introduces new questions, right? Because
Hmm.
now you're not thinking as much about broader things. Um, the I would say my biggest impression, sort of shift, is that is my perception of how Tesla is just like generally going at the this like that it's less about them having a vision for what the end game is and going straight to it, and it's more about like having an idea for what the road is, but getting something working now and then rapidly iterating on it, which you know that was something I was sort of aware of before, but I'm much more. It's a much more concrete component of my sense of how Tesla is going at not just this problem. I mean, other problems
Yeah.
also.
Yeah.
Now I've been reframing a lot of my understanding of what they've done in the history in these terms, and it kind of resonates with a lot of stuff. Them getting a product out there,
Hmm.
getting something that that gets them something concrete to work on, and then iterating rapidly
Yeah.
to sort of in the direction that they think the product needs to go, but they want they don't want to spend a lot of time thinking about stuff and then do something after 2 years of thinking. They want to, what's the closest thing we could build today
Hmm.
that is an approximation to what we want, and let's use that as a platform. And now let's iterate to get to where we want to go.
Yeah. I mean, I was thinking back to 2019. That was kind of the first almost AI day. They call it Autonomy Day.
Mm.
But the things that they presented there and also updated last year, it it really seems like Tesla's executing on what they're saying they're doing. Like for example, back then I think Karpathy was talking about kind of 3D rendering, the beginnings, the potential of that,
Hmm.
and it was very early on. But fast forward to last week, you see them spending a huge amount of effort and compute on occupancy networks and also on auto labeling. Like these things 3 years ago, they were just like, you know, just ideas that
Mm.
they're hoping to get to. But now, fast forward a few years, like they're doing this at scale.
Yeah.
So this is impressive. Like I think these early updates by Tesla, it really gives credibility that you could review and rewind and watch their previous presentations to see if they're really executing on what they promise. And yeah, it's quite impressive, I think.
Yeah, scale is another. I mean, and you sort of understand their scale in the abstract, just like you understand in the abstract. We only see 3, 4, 5 people in front.
Mhm.
They brought a lot more engineers out this time, so you get
Yeah.
more of a feel of like the depth of the team. In the abstract there are a significant number of people out there, but then you see them,
Mhm.
or I mean, looking at the actuators, like I know that Tesla's got the capacity to design these things, but then I actually look at the actuators like sitting on the table and
Mhm.
I thinking, man, s- uh, they did this in 6 months. They've done so much in 6 months. Like the pace
Mhm.
is really crazy. I'm actually and the I think I said going into this, we talked about, and
Mhm.
other people have said it,
Mhm.
that it's easy to not be impressed when you look at kind of a clunky robot sort of moving around. But the flip side is like they did this robot from scratch in, I
Yeah.
don't know, 9 months or something like that, and just getting the mechanicals and that kind of time with custom actuators. That's
Yeah.
another thing. I mean, the Bumble was a lot of off the shelf components, but the second generation thing, like they're 3D printing the components to go into those motors. Like that's from scratch designs on these things. Just designing an actuator in like 6 months is like a huge, and then they did a bunch of them and they did all the structural analysis for the body to decide what they were going to do on this stuff. They probably went through a bunch of designs and narrowed it down. They did all of these, computer studies of what they needed to do. Like it's just a
Yeah.
really impressively large amount of work that they've done in this
Yeah.
window of time.
Yeah. So what I want to do is I want to break it down. We'll first go into the Tesla bot Optimus, answer some questions from people from Twitter, and then go into FSD and Dojo. And then we'll try to do maybe a separate episode on Tesla removing the ultrasonics, and we'll try to put that out maybe first or something. And this full episode later. So Tesla bot. Let's go to actuators. So I
Mm.
know we've talked about this, and you've kept on bringing up this point that for robots to really take the next big leap, someone like Tesla needs to build custom actuators at
Mhm.
scale. So, were you kind of satisfied with Tesla's efforts that they showed with actuators, and was that what you were expecting them to do?
So it's, yeah, more or less. I mean, the actuators we eventually need, the reason we need a company like Tesla to do something like this, to do a really clean sheet. And this is why, when you asked me, I said, I'd like to see them do a humanoid robot,
Yeah.
because there are a lot of really core technologies to make a really good, like the final humanoid robot, the one that we see in 5 years, the one that we see in 10 years, that are going to need a clean sheet rethink. Or they're going to need a lot of iteration from where we are to get down to where that is. And to do that in a reasonable amount of time, you need a company that moves really fast on that kind of stuff. They're not going to look to, what kind of business model could we build around what we can build off the shelf today? And then let's
Mhm.
work really hard on our business model and making money and that kind of stuff. More, you know, they're just really focused on the engineering, like either doing the end design or iterating to get there rapidly. So there's a lot of potential in actuators that we're not seeing yet today. I think the stuff that they're showing is a great start. Like starting from, if you're going to try to do the minimum viable product and you want to have something working in a year, you have to do something that you can get working and get into some level of production in a year. And the actuator that we're going to be able to do in 10 years, well, you can't do that in a year. So you have to do
Mhm.
something before then. And I'm pretty happy with what I saw. The specs are pretty impressive. I mean, they're getting a lot of power density. They're getting, good speed. I mean, the stuff that I saw looks like it's got the potential to make a really useful
Mhm.
starter robot, say.
Yeah. Okay. Yeah, it's interesting because the Bumble C, um, I guess that is kind of I would say the an old generation, kind of what maybe a standard type of robotics effort would do with off-the-shelf components. But this new version of Optimus, it's like completely redesigned. It seems like from Tesla's custom actuators and everything. What kind of improvements do you expect from, let's say, the Bumble C robot? Like, let's say next year at Tesla AI Day, what do you think this new Optimus that at least the framework that they showed last week with the robot, like what do you think that it'll be capable of doing in 1 year?
Well, so a big caveat on this is that the capabilities are all entirely software limited right now. Like both of these bodies, if you had arbitrarily good software, like if you took Bumble and you spent years and years iterating on software, or if we had a really mature sort of humanoid software suite that was out there already that they could build on, then we would have seen a graceful Bumble C moving around, and it wouldn't have been as scary to like take it off the tether the first time. Its ability to manipulate things in the environment, to understand where it's at, like all those would have been much more sophisticated. Robotics, like there's a hardware component to this and there's a software component. There are a lot of people working on the software component, mostly research labs, but also some industrial labs are working on that stuff, a humanoid robot in particular. And that is it's going to take longer to do a really good job with that than it is going to take to do the hardware. I think for Tesla to do the hardware, because I think we could see, 5 years from now, I think we will be, Tesla has the capacity to build a really compelling, a really useful, really, performant robot that's reliable and can be manufactured at low cost and high volume. I think they have the hardware skills to get that. The software is harder to predict because it requires, for lack of a better term, breakthroughs,
Hmm.
right? We have to get up a number of humps that, might happen tomorrow, might happen in 6 months. One of the interesting things that's going on in neural networks and deep learning right now is that we see these phase transitions where somebody figures out the right way to
Hmm.
approach a particular problem with neural networks. And then in the span of 2 years, the whole field just completely changes. I mean, we saw AlphaFold did this. We saw AlphaGo do this. Language models did that. Recently, we're seeing like Stable Diffusion, these other, language versus image models doing this. So there are a number of those that could occur in the robotics field or that could occur in the self-driving field. And if we get one of those phase transitions, then all of our expectations for the software, well, we can pull those in by years. And if they don't happen, then if they keep sort of incrementally iterating on the approach that they're doing right now, well, you get there, but you get there on more of a slower glide path. The hardware, I feel like, doesn't take. It's more iterative engineering,
Got it.
analysis. And what we've seen with the cars, right? We've seen some super clever things with the cars, like the casting. That's great. That's a really great sort of out of the box thinking kind of thing. Although, Sandy Munro would tell you that people have been talking about it for a long time. It's not a novel idea, but they actually went out and did it. But most of what we see, like in what they did in the motors, they didn't come up with a radical new motor design. They took existing motors and they refined them and polished them, and you do eventually start getting next level performance, but you get it step by step as you go there. And I think that's what we see with the robot bodies over time. They're going to iterate on the robot bodies, and we're going to see refinement. I'm pretty happy with the number of degrees of freedom that the core design. They stuck with the envelope of a human body.
Hmm.
That's great. It makes it much more reasonable to drop into human tasks. It makes it a lot more reasonable for a human being to visualize a task, to understand how to instruct a robot to do this thing, because they take what they would do with their own body and then get the robot to do that, which, if robots have radically different shapes, that's a tougher thing to do. So they stuck with that. They put enough degrees of freedom on it to actually do a good job of mimicking general human motion. And the range of motion that they put on the joints and whatnot, similarly.
Yeah.
It also seems like they're doing a decent job of providing sort of like speed and torque and force capacities are roughly in line with a human being. Like they're, the fact that they got that on their second try, like that's pretty good. That's a good sign that they can go. In the future, we could see more degrees of freedom, more refinement to what's going on. I would especially like to see more degrees of freedom and control in the hands for dexterity and that kind of stuff. For manipulating relatively large objects, I feel like, they can do that right now. But the hand they have right now, it's not going to pick up a soldering iron and solder a circuit board. There's going to be stuff that it's just not well suited to.
Sure. So for hardware, so you're saying the hardware side is more predictable in terms of the improvements because it's engineering, it's incremental. The software side is dependent on how fast the field of AI progresses, especially with maybe images, video, neural radiant fields, etc. So with the hardware side, with what they showed at AI Day, the second version of Optimus, do you think that Optimus, if they show it next year, will not be limited by hardware constraints, meaning it'll be basically a software limited in the sense that hardware wise, it could do all the motions that Tesla is saying it'll be able to do. It's just that how well it can do it depends on the brain, right? Is that kind of your assessment of? And then every year it just gets incrementally better, right? As they iterate on that.
Yeah, it's I mean, you'll see simplification. You'll see improvements in robustness. From time to time, we'll probably see them like, oh, we should have done this joint this way. Or here's a thing that we could do that would trade off a bunch of parts for one other simpler part that we could do, where you'll see kind of architectural adjustments to what's going on. And it's possible, that they have, there are lots of small decisions that you make about, how you're going to approach creating a joint on a robot to get, the range and power and reliability and it wouldn't be that surprising to see some of these things kind of change. But I'm sort of expecting that we're going to see iterative changes to the robot body without like any big steps away from that. But that said, software is totally the limiter. If you had the perfect software for the V2 robot that they had today, it'd be playing basketball. It wouldn't be barely trying to walk around on a stage. Software, we're really far away from what the software will eventually be able to do. We're not nearly as far away on the basics of building a robot whose mechanicals can do, basic human stuff like, carrying boxes around a factory. Yeah. Like we can do the hardware on that. I think Tesla basically has the hardware to be able to do that. Like the V2 robot that they showed us, there's all kinds of basic tasks that the hardware is completely appropriate for in a factory right now. But the software, probably not super close right now.
So would you say over time, Tesla's advantage with the AI robot will be on the software side? Because it seems like initially with the hardware, they do have an advantage because they're doing custom, actuators and custom design, manufacturing at scale. So they've got a cost advantage, a performance advantage. But over time, would you say that other engineering efforts could, replicate, duplicate that? They might not have the economies of scale yet, but at least it'll be easier to replicate than the brain side, because the brain side seems like it's immensely more complex than the hardware.
It's there are different ways of thinking about the relative advantages that Tesla has in this space and how the external environment might evolve. I think, Tesla definitely has a big advantage in the hardware because of their approach to building hardware. They put a lot of resources at it. They're very engineering heavy. They think a lot. They're manufacturing first. Like the potential for Tesla to get to scale on a useful humanoid robot before anybody else really can. I think that there's a very high potential for Tesla to do that. barring some other, large, well-resourced entity deciding that they want to go head-to-head on this thing and really pour a lot of resources into it, I'd be kind of surprised if somebody else can match Tesla for the robot they want to build, right? You could see other people building robots that have a different performance envelope or different target applications and getting there faster for whatever reasons. Like, if you have some very small volume, super precise robot that you want instead, sure, Tesla may not be well suited to some of those applications. In software, Tesla's strength is, I use the FSD program as kind of a guide for thinking about Tesla's relative strengths and relative weaknesses. FSD is, for the most part, if you look at the core technologies that go into the software, there are things that other people pioneered and developed. And then Tesla adapted them, inserted them into their system, understood how they worked and didn't work, how they applied, and then they iteratively refined them, integrated them with other things. Because of their pace, like how fast they want to move, I think Tesla has a big advantage. I also think they're, small, low communication overhead teams of people putting a lot of time. Like organizationally, that's a way to iterate quickly on these kinds of things and, figure out what you want to build and then build it.
Yeah.
A lot of people will interpret the software that Tesla's doing as like stuff that they're getting from other people and kind of cobbling together, right? And there's a way in which that's kind of true. There are some things that they're doing that seem completely novel to that language of lanes thing, like that came out of left field. Like, I don't know if there are precedents for other entities trying to use a language model to solve something, which is kind of a spatial problem, aside from, the straightforward vision transformers. I wouldn't be surprised if there are people doing it. I don't know if anybody had this particular, like that was a thing that I thought was really innovative and creative. And if Tesla did invent that, like kudos to them. That's a great piece of tech. But they didn't invent Nerfs. They didn't invent occupancy networks. They didn't invent, the convolutional networks they have, when I was still looking at what they were doing in convolutional networks for the camera stacks, you could see them adopt just something right off the shelf that somebody else was doing. And then you could see them start playing with, let's make it wider, let's make it deeper, let's change the number of neurons in this layer, let's try a variation on this block they have and run it in parallel, sort of incrementally extending the architecture. Eventually you get to something which might be quite different from what anybody else is doing, but you're not doing it by having a bunch of PhDs sitting in a room doing math, trying to figure out from first principles, and then doing a ton of experiments to prove out a new technique. They're definitely taking tried and true stuff, for the most part, putting it together, and then iterating on it to get it to work as well as reasonable with a comfortable dose of completely novel stuff that they're putting in.
I mean, I would say that one of the key factors is the speed at which they're taking the stuff in research and putting it into actual shipping product, but at scale. They're not waiting 5 years for it to be mature. They're taking ideas that are the building blocks, but I think also building scale. They're having to, invent maybe not like the foundational ideas, but they're having to build all the things that are required for scale. All the QA, all the testing, all the storage and compute. And that's like a huge piece of the puzzle, I think. And I think that's one of the unique things it seems like Tesla is doing is how the time frame between which the stuff comes out, occupancy networks come out in research, and then they implement it and then go crazy at scale. And so, I mean, that's kind of one of the most fascinating parts of Tesla's AI, I think, for me.
It's really impressive, like how short the gap is between a completely novel idea comes out and you see Tesla has integrated it into a product. I suspect they must have, a significant number. And in fact, I suspect one of Karpathy's tasks when he was there was like, find papers that seem like they have something useful, get a prototype, play with it, try to understand what the implications of this new technique are. Is it something we should adopt? Yeah. And as I was, previously I was describing, there's kind of this difference between the hardware and the software where the software is much more dependent on developments in the outside world. So you want to be paying really close attention to that. You want to adopt it as quickly because there's this constant stream of these developments that come out that 10x some core capability that you really care about. And you want to identify that as quickly as possible and get it, not just because you're in a hurry, because you don't want to waste a lot of time doing the wrong thing. Like however you're doing it, and if there's a better way and it's not the way you're doing it right now, well, all the effort you're putting into doing it the wrong way is just lost. You're just going to throw that away anyway. It's pretty, it reminds me a little bit of this, Elon once commented on battery developments with Tesla, and he said, we have a group of people and they follow basically all the battery developments. And we rank them on a scale of 1 to 5 about how likely they are to be useful, like how much we should be paying attention to it. I can imagine there's a similar kind of structure looking at other people's software innovations, other people's neural network innovations, and let's keep an eye on this one. Let's try to get this one integrated. This one down here we can ignore, putting them in bins and then have a team that tracks those over time.
Yeah. Yeah. I mean, one example of Tesla moving fast with AI is kind of human labeling, porting over to auto labeling. It's just like, it seems like a couple years ago, Tesla, was making this big investment in human labeling, like 1,000+ labelers, all this stuff. And then a blink of an eye, right? A couple years later, it's like, the whole approach has shifted, right, to this massive auto labeling approach with videos, almost labeling. And it's just that the speed of which Tesla decided to, move away from, I won't say move away, but to emphasize more auto labeling is just, it's impressive.
The scale and the degree of refinement that they've managed to get to on the auto labeling effort this quickly is super impressive. The multi-route thing I find really, so they they have a piece of ground and lots of Teslas drive across it over time, and they take the observations from all of these, and each additional car that drives through this set of things provides them with a new set of observations, and they can add that to the bag of observations that they have for this intersection, this roadway or whatnot, to each one of them refines, you get that much more accurate with where the curb is, where the sign is, what the lane markings actually are. You get to see it in all these different, and so they, having a bunch of cars drive through it, and then from having a lot of cars drive through a route, you decide what the ground truth is, and then you take that ground truth from those and you push it back to all of the samples that went into that go into your database. So. Every time, the number of cars that's driven through an important intersection in San Francisco doubles, they can just take that data, dump it into the model they already have. It gets that much better, and then push it out to all not just the new samples, but all the old samples too, relabel them. So the labels, even on existing samples, can be refined and improved over time.
Yeah. I thought that I thought that was one of, I don't know if it's per se novel, but it's very creative use of crowdsourcing data real time to quickly improve, the ground truth, but also using that to create simulation of, let's say, San Francisco quickly. What's your take on that? I mean, to me, it seems pretty impressive that they could crowdsource the data quickly, not just use it for ground truth for the cars, but also have a second route of simulation where now you're having more data that you could feed back into the system. Yeah. What's your kind of take on that?
The synergy is great. They've got this ability to grab data, and then they've got this simulation capability, and being able to take your fleet data and use it in your simulation, and then generate output that feeds back into training for the fleet. It's pretty cool that there's some interesting synergies that I hadn't expected.
Yeah.
I was surprised to see them trying to use Nerfs to. Initially, I didn't understand what the incentive was for using Nerfs to generate, because I see now, to jump to the end, that what Ashok once would like to see, they described this as his weekend project he's been working on for a while, is to basically have the system be able to generate a supervision signal that can be fed back into the cameras from the intermediate results that you're calculating from the ground truth and whatnot. And so that's what the Nerfs kind of close the loop on training. So if you were to want to train end to end, you want to be able to understand what the what the internal representation should be based on the output signals directly that the camera sees. Right up until pretty recently, I mean, the Nerfs give Tesla the potential for closing the loop and essentially, taking camera inputs, running them through a neural network to the internal representation that you want to be able to drive the car, and then pushing that farther through the Nerfs back to what the cameras should be seeing, right? So then you can compare what comes out of the Nerfs to what went into the cameras, and you can close the loop. The thing about closing the loop is now all the other stuff becomes unnecessary. You can just grab tons and tons and tons of video from the real world. You run it through, because the output, once you run through the whole thing, if you get the camera output back out, you've got a really simple way to just compare what went in to what went in. So this is how language models
Interesting.
work, right?
So it basically trains itself, because the camera output is
it's self-supervised.
Yeah, it's self-supervised. So whatever the nerves will predict what the 3D or scene is, but the cameras will basically train it, of what it should be seeing. So this is interesting. So let's talk. I want to. I mean, tomorrow we'll go into more of the slides and technical, but I think this idea of the occupancy networks and nerfs, a lot of people are interested in. They want maybe a clearer, more simple explanation. So let's take a step back. So from what I'm seeing is Tesla's kind of has simplified some of their AI structure, where it seems like a lot of it is going through occupancy networks and auto labeling. Like they pointed, those are the two kind of things that a lot of their data will go into before planning. With occupancy networks, my understanding that is basically this coarse volumetric kind of representation of the 3D space around. And also they could track the velocity and direction of these objects moving. But my understanding from AI Day was that it's not detailed enough to make like maybe specific, like it's not detailed enough to rely completely on for planning. And so they'll take the course data and then they'll hone in on different parts of the scene to get a more accurate representation and then make decisions off of that. But it seems like what nerves or these neural radiant fields and this kind of ongoing development, it will allow the cameras to not go to a volumetric kind of these voxel coarse things, but actually go to a really detailed 3D like representation of each object in the whole scene. And it seems like that is what, I mean, Ashok mentioned it at the kind of the end, but it seems like that could be the next big kind of jump, next big area for Tesla. If they can actually go from camera to not just a coarse, voxel, whatever representation, but actually go to a detailed 3D scene where it's actually accurate and they understand every object, what it is and where it's moving. It seems like that could be the holy grail of FSD. I mean, is this like, what kind of feedback and what kind of things can you kind of input into all this?
So the first time they presented Nerfs I can't remember. I guess Ashoka's talked about him at the CVPR that he did. And then I think they touched on him briefly at the previous AI Day, but I'm not certain about that. I was a little confused about the Nerf thing. Internal to the software, you need to at some point create a representation of the environment, which your planning software can use to make decisions. And so perception is basically building this internal representation. They've looked at a couple of different ways they've gone through this cycle of doing that a couple of different ways. In the beginning, they just had camera view, this is a car, this is the drivable space, and the planning network tried to work with that. And they got a certain level of success, and it wasn't good enough. And so at some point, they go to the bird's eye view as a way of, because they're finding that the cameras are having problems with depth near horizons and stuff. So the bird's eye view is a way to get all the cameras to cooperate, to give you something where the layout around the car makes more sense. And once you have a bird's eye view, sort of, all of a sudden the planning gets a lot easier. You've kind of got this 2D map, like a video game or something, and the planner can look at that and make decisions about that car's going to cross my path. This one is stopped. I'm far enough from this curb when I do my turn, like all of those spatial-based decisions. Of course, when it's 2D, you don't have a lot of height things that you need. So going to a voxel sort of, volumetric approach, that makes a lot of sense. And they initially did that with bag of points, and then they had a downstream algorithm that was, this is when Elon was commenting on the bag of points, and when they started using GPTs to consume those instead of C code. I forget when he was talking about that. Was sometime in the last year. Like that was a topic that had come up, and he was talking about how much better the GPTs are. These transformer-based neural networks that are trained, that's generatively pre-trained neural networks, that they were better at consuming this giant bag of points and turning it into actionable information. And once again, it's to create a set of perceptions that the planner can easily digest. The planner has a pretty difficult job. It has to anticipate all the possible future evolutions of the situation that you're in and decide what the best course of action is to pursue your goal. So you want to distill that down to the smallest number of most abstract, highest representational power. Like a car, you can imagine seeing a car as a bunch of voxels. Or you can imagine understanding a car as that's a Chevy Blazer moving 40 miles an hour in this direction. That's a higher abstraction, and it's easier to make decisions based on. So they tried to go to the Chevy Blazer right in the beginning, and in the 2D camera view, it wasn't good enough. And then when they went to the 3D top-down view, now you kind of have voxels, right? That kind of falls out of the bird's eye view because you're drawing a grid and deciding what's at every point inside the grid. But now you have a piece of software that has to consume a bunch of voxels and turn it into a Chevy Blazer so that you can make a decision about that truck. That was inefficient, and it had accuracy limitations. They went to a neural network to consume that. So now they got a neural network taking the output of that giant bag of points and making the Chevy Blazer. But then they had issues with static objects and stuff. Like, what do you do with a pile of dirt? Like, how do you categorize a pile of dirt? Everyone is a different shape. So they had to have the occupancy grid, essentially, to deal with all the objects you don't have categories for in the world. And after they'd been working on it for a while, they realized that was actually a really good way to do the Chevy Blazer too. So now the Chevy Blazer goes back to being voxels or whatever, kind of in a sense. But now at that point, they have already developed the GPTs that can take the voxels and turn it into Chevy Blazer or stop sign or whatever the deal is. And that's sort of the evolution that we've seen. They've got this intermediate product, which they're currently calling occupancy network. Is kind of an interesting term. Occupancy network, it actually refers to the neural network and not to the data, the representation. And I think previously I said, let's use the term occupancy map to describe the representation itself, like this volumetric representation that is, that's surrounding the car. So the Nerfs, they do this other step. They're doing a Nerf that can take the volumetric thing and turn it back into an image. So you could ask the question, like, what is that really useful for? Well, there are a couple of things you can use it for right away that are really interesting. One of them is, say, I want to build a simulation based on my volume. In other words, the car drove, this was something they showed us at the last AI day, I think, car drives through a situation and we had a problem with this situation. We want to turn that into a simulation so that we can vary how fast the cars are, what the lighting is, and all that kind of stuff, and understand this problem the neural network is having. So it'd be really great to have a piece of software that takes the recording that produced the volumetric thing and turn that into something that we can use in a simulator. It's got to turn it back into images and whatnot. So the Nerfs are kind of a way to do that. They help do that sort of thing. But I think the ultimate goal with the Nerfs, the thing that if you could do it would be really, really powerful and would really sort of change the playing field in a significant way. And the reason I think Ashok is interested in this, the big payoff is, if you get the Nerfs to regenerate what the cameras saw from the volumetric thing. Because the thing is, now you've done two things. I have the camera coming in and I'm turning it into an understanding of the situation, this occupancy map.
Mhm.
Now, if I can set that part aside, and I can have an independent process that can take the occupancy map and generate the Nerfs, well, the Nerfs are like the camera views, right? If that whole process is differentiable, you can train it end to end now. And all of a sudden you're in a world where we can just take lots of video, and every single frame of video we get, and once you have that, you can start doing experiments where you change these intermediate representations. And this is sort of the progression we've seen in a lot of other areas with neural networks, where you start out and they're broken into different blocks. But once you get to a point where you can get all the way to the end, and the thing about it being differentiable is that once the whole process is differentiable from one end to the other, you can run back propagation. That's the learning process that neural networks use to just get better. Once it's differentiable from one end to the other, now you can go hog wild. You can just feed anything into it. You can backprop the whole thing, and suddenly the level of automation has gone up. So so now it's just computation, right? And you can do lots of simple, even automated experiments where you can have a piece of software that trains the neural network and then changes something and then trains it again. Is it better or worse? And then you change something else and you train it again, better or worse. So, it sort of sits there inside a computer and just gets better and better. I've been using recently this sort of the evolution of we can do translation from one person's voice in one language to voice in another language. And the way you used to have to do that is you'd start with sound, you'd run it through a spectrogram, you'd break that down into phonemes, then you'd have another module that take the phonemes and try to make sentences out of them. The sentences would have errors, so then you'd have this language model that sat on that, and it would fix the missing words and that kind of stuff. Once you had the words, then you had a translation model that would translate it into the other language, and then you would do all those steps separately. And in the beginning, some of those steps are software. Some of them are neural net. I mean, in the beginning, none of them were neural networks when speech recognition started out, and these were all sort of built as blocks. Once they started being neural networks, somebody would take one part, make a neural network, another part. At some point, somebody had made neural networks out of all the different pieces, and so you could try to just string all because neural networks are differentiable. Once you string all the neural networks together, now you can try to go end to end, and we do see. Like Microsoft, this has been a big area of research for them. They can just take lots of language, record it in different models, and they have a single thing, and they train end to end just from the sound right back to the sound. So there's a thing that happens when you do that. When you started out, you had this concept of phonemes, right? And when the sound has to be converted into phonemes, that works well if sound can be well represented by phonemes. And it turns out that phonemes, they're an okay representation of sound, but they're not perfect. There's all kinds of stuff that phonemes don't capture. Like we have in English, I forget, 40-something that we like to use. And it turns out that if you try to stick with phonemes, there's all kinds of nuance and stuff that you lose. Once you have the neural networks running end to end, instead of if the neural networks are inventing their own phonemes on the process of training, you can say, what if there were 100 phonemes? And you don't tell what the phonemes are. You just tell, okay, you can use 100 now. Figure out what they are. And what we find is that by doing those kinds of experiments, what you see is the performance improves. You figure out what the bottlenecks are, like the iteration on the process. So if Tesla can get to where they can get Nerfs out of their volumetric representation, and they go from the cameras to the volumetric representation already, there's the potential to close that loop and rapidly speed up the pace of development of this technology.
All right. So this is interesting. So let me see if I'm getting this. So because some people ask like, oh, why can't Tesla do end-to-end right now? It's like mu0 or with game development, et cetera. My thinking is in a game, it's a closed loop system. You know all of the variables. And so like the game, you could just run the game a million times and, it's like you could predict each move results in another, situation that is predictable within the rules of the game. With driving, there's so many, there's this unknown part where if you can't perceive the environment accurately enough, then it's like your whatever million scenarios you train, you simulate on that, it's not gonna be that helpful because it's not the real thing. But if your perception, let's say you do the cameras not just to Alchemy networks, but actually to Nerfs, where you actually are seeing everything in 3D accurately. It seems like in that type of environment, you could go ahead and run a million variations of different things that'll happen, and it actually helps because it's an accurate, representation of the scenario. It just seems like that would be this massive, massive jump in training and accuracy and possibilities. Is that kind of what you're inferring here?
Um, so you can train driving end to end. There are people doing it. The best result that you can get training end to end is not very good right now. The reason to take a problem and not training end to end to break it down is because you get a couple of things when you break a problem down into multiple networks where you kind of understand what's passing between them. You get these little diagnostic blocks where you can start asking questions about what would be a better if you just take a neural network and you slice it at a couple points, and you look at what's passing from one stage to another, and you go a step further and you constrain it to have some kind of interpretable meaning at that point, you now have a way of looking into the system to understand what it's doing as you try different things. And you also have a way of exploring the internal representations because you can vary those things and you can see how they affect the system. If you go end to end, you're basically saying, I'm going to make this really big, really complicated black box. And there's literally there's a countable infinity of different things you could put inside that black box. Trying to explore the space of all those possibilities just by trying stuff is it's super intense computationally. And I think most people would say that's an intractable problem. If you don't get lucky, you're not going to be able to do that with any reasonable amount of computation. So when you're doing end to end, you're forced to lower your goals to get something that you can do end to end, and then you try to get better by incrementally raising your goals and hopefully get to that point. That's sort of how you need to approach end to end when the stuff in the black box is really complicated. If we look at sort of notable advancements in neural networks in like the last 10 years or something, they mostly don't get done end to end. Like when DeepMind did AlphaGo, they didn't put a bunch of neurons in a box and go at it. They started with some kind of understanding of what they wanted to do and some intermediate representations. They did eventually get to something which is basically end to end, but they did it by initially breaking it down into blocks, refining the blocks, understanding what was going on, iterating through those things, making the individual blocks better. And at some point, at those interfaces where you have the human understandable thing, if the piece in front is working pretty well and the piece in back is working pretty well, you can start saying, okay, I'm going to just let the neural network, instead of constraining it to what I think should pass between block A and block B, I'm going to let the neural network pick it. And if you've got an input block and an output block that are both basically doing okay, there's a decent chance you can iterate. You can let the neural network take over that task. You can let the search algorithm that's basically trying to understand that, figure that out, and converge on a different thing that's not human understandable, but that works better as that intermediate thing. And in our experience is that when you let them do that, everything gets a lot better. So the argument for doing end-to-end is don't even try to have any human understandable stuff in the middle, because we know that in the long run, trying to make human understandable stuff in the middle, it degrades the performance of the system. Like when you can get rid of it, it always gets better. That's the argument for end-to-end. The downside to end-to-end is if we don't put some if we can't break it up into modules, if we can't break the problem down into pieces, it's much harder to it's much harder to make progress, right? Because you're having to treat the whole thing as a single unit where there's all different kinds of complicated interactions between the parts when you make something. If I can break it down into a simpler subset of a problem and work on that, then, what we see is that sizable problems that get broken down that way in the real world, we make progress on them faster. And, I mean, almost without exception, all of the really notable advances in neural networks that we've seen in the last 10 years have taken that. The first group to get really outstanding performance was taking that approach. And we see very few examples of entities that started out end-to-end and just were managed to be the first to produce a good solution using end-to-end. End-to-end is great. For problems, I mean, there's a space of problems where you can just go at it end-to-end and good results get produced. The more complicated a problem is, the more difficult it is to just start out end-to-end and get there in a reasonable amount of time.
Sure. All right. So I want to go back to this, the bot, and this idea of the software versus the hardware. So someone tweeted or replied to one of my tweets was saying something like, "Oh, I can't wait until the robot becomes like a ball machine for playing tennis."
Oh,
right.
yeah.
So that Optimus could basically shoot the balls and someone can play tennis. And I was thinking about that. I'm like, well, the next step is actually really playing tennis, against the human. It reminds me a bit of the whole RoboCup challenge where the dream is all these colleges compete against each other, with robot soccer teams. And the vision is one day an intelligent robot soccer team will beat a professional soccer team, right? It's just a matter of time.
Yes.
That's the idea. So I was thinking about this tennis robot, and I was like, like before Tesla got into AI and robots, the idea of a professional soccer team getting beat by robots seems like at least a couple decades away, right? But when I look at what Tesla is doing, especially bringing that body, with custom design actuators and the developments they're doing with the brain, my question is, how fast do you think will the hardware be ready to, for example, play tennis against somebody enough where it's mechanically possible to actually play? And then the second question is, when will their brains get good enough where actually we'll be able to control that body enough where actually could beat, let's say, a very good tennis player? So, there are two different ideas, is when the brain will be ready, but when will the hardware be ready? So I guess the first question is, like, when do you think the hardware, do you think what they showed version 2 can actually play tennis when it gets better? Or
Probably not the way a human plays tennis.
Okay, do you think it'll take a few or several more years before the hardware itself can actually play tennis adequately?
Humans, man, that's a really interesting question. Well, okay, first, as I keep coming back to this, the big limiter is software. If you had, really, really good software, Optimus could probably play tennis in the body he's got right now. Could he beat a pro? I don't know. He's got few enough he's enough constrained in the degrees of freedom he has in the range of motion. And probably, we don't know what the, power speed of the actuators is right now, or how efficient the body is. It might, if Optimus is trying to play tennis like human beings, he might be thermally limited. That is, the current design, it might not be able to operate at high output for long enough without overheating for it to be a problem. So you might have to have radiators or other designs and that kind of stuff if you wanted to do that. Depends on how efficient the electronics are, how efficient the actuators are. It's probably got enough degrees of freedom. So this is one of the things that I mentioned before. Like, if I think about the hand holding a tennis racket, it can probably pick up a tennis racket, right? Is it going to have the kind of flexible dexterous grip and the kind of wrist motion to be good at returning ball? If it has plenty of time to set up for a ball coming, that is, the restrictions on its motion are going to cause it to have to do extra movement because it doesn't have as many degrees of freedom as a human does, in order to return a serve that a human wouldn't have to do. How much does that impact it? Could it do it at all?
Yeah.
If you're not playing very fast, I would guess it probably has enough degrees of freedom to do that, and the existing body, more would be better. I don't know what the power capability of the current actuators is. And I would say, one of the biggest weaknesses is, the hand has a pretty constrained grip. When a human holds a tennis racket, every single one of your fingers is doing, it's not like your fingers just close like a clamp on it. To what extent does that hurt you? Some, I don't know how much. It'd take a simulation to sort of figure it out.
Yeah.
But I think Tesla is likely to get to a body that can play tennis before they get to software that can play tennis at the current pace of development.
Yeah.
So I think I mentioned before that we do get these discontinuous advancements where some subset of things we want to do with neural networks suddenly kind of leaps forward because somebody just figures out the right approach. And it's entirely possible that some of the components of what Optimus would need to do to play tennis will undergo some of those transformations, in the next few years, and that will rapidly accelerate my expectation for what that. So, barring that, we sort of imagine if all the techniques we know work today continue to incrementally improve just by scaling and whatnot. And if that latter case is it, I would expect the body to be ready to play a good game of tennis before the software is ready to play a good game of tennis. But I would love to be wrong about that. Yeah. There have been some. So reinforcement learning has been used to train robots in simulation. Mm-hmm. The grace and efficiency and capability of robots, imaginary robots that we can train in simulation. Some really impressive things have been done. I mean, robots that move in simulation, they're indistinguishable from the level of grace and capability of a human being, and that's really impressive. So, we have existence proofs that neural networks can get us there. Now, the robots in simulation, they're much simpler in many respects than robots in the real world. It's expensive and risky to have your robot doing backflips in real life, because you go through a lot of robots that way before you get the backflip to work. In simulation, you can just do that. Yeah. So that's part of the reason why the simulation is ahead. And part of it is just that robots in the real world are also more complicated. They have more things that they have to deal with. Yeah. So the software will get there. Yeah. I'm really confident of that.
Yeah. So it's interesting because I think this tennis example, it triggers some people because they're like, oh my gosh, that's never going to happen in my lifetime. Robot actually beating someone at tennis or something. But I was a few months ago, I was looking into ping pong robots because I was thinking of getting a table tennis thing for my kids. And they actually have these ping pong robots with cameras that basically can beat almost anybody because and
they don't play like a human does.
Yeah, they don't. But the idea is that's not the difficult. If you have a robot, just if they're standing still at a tennis court, they could probably I'm sure Tesla can make something pretty quickly. I won't say quickly, but I mean the hardware could probably get there within a year or two to maybe to swing the racket back and forth, and they've got the brain to be able to do that. A bigger question, I think, was probably how fast it can move side to side and forward and actually accurately.
You've seen there was a lab. This is several years ago. They built a robot arm that would just catch things you would throw at it. Right, so it was just bolted to a table, and you could pick up a rock and toss, or you could pick up a bottle and flip it end over end. You could pick up a tennis racket and flip it end over end. It used a camera. It predicted the trajectory, and it had a fast moving robot arm that just snapped out there. And it was pretty shocking, the random stuff that he could just pick up and throw across the room or whatnot, and then just grab it out of the air. Right, so it's cool. Yeah, if you constrain the problem a little bit, robots can do a lot of this stuff.
Have you seen the videos where they take a robot on these NBA halftime games and they'll do it from half court and the robot will just sink these 3-point shots over and over and over?
It should be 10-pointers, right? Half court. Yeah.
But you think about it and you're like, oh man, robots will never beat an NBA team, right? But
if they don't play like a human, if you want to build a tennis robot to beat a human being, one approach is make it do a 400-mile-an-hour serve. Right? So there's just no way a human can return it, right? Exactly. And then it just has to be able to volley well enough to eventually get the serve, right? And then it wins every game.
Exactly. Yeah. Yeah. That's the thing. I think our human, when we compare ourselves to robots, we're not expecting a robot to do like a full court, shot or something
Yeah.
like crazy. But
Yeah.
they're not limited in the same way that I think humans
Yeah.
will be. And so it's just, yeah, it's fascinating to think about this
And
stuff.
that's a interesting sort of just that framework of thinking about
Mhm.
robots and
Yeah.
people's expectation of robots is that, we tend to think of things the way, in term in the first, when you ask somebody how hard something is, the first thing they do is, well, how hard is it for me to do it, right?
Yeah.
And they don't go to, well, what if I could, lift a car? What if I could move my arm at the speed of sound? What if, there's all these other possibilities that you just disregard, right? You
Yeah.
use your intuition and you imagine how hard something is that way. In the driving thing, we people often will make there are certain things that are really tough for a human being. Like for a human being to drive a car in a complicated situation where lots of pedestrians close to the car and cars in front of you and back of you, sort of like you're moving like through a parking lot, and there's lots of pedestrians and cars maneuvering around and stuff. And that, from an information standpoint, that's kind of overwhelming to a human being because you got to keep track of stuff in front of you and behind you at the same time, which is like that. Just intuitively, it seems like super when there's short reaction time stuff,
Yeah.
and you've got to be looking forward, backward. To a machine, that's super trivial because it's looking at all those things at the same time. Like if you've got 8 eyes and you can
Yeah.
see in the back of your head, that's just trivial, right? It's a
Yeah.
really easy problem to solve.
Yeah. I mean, it's interesting because like I think of Steph Curry who does, these alley shots before
Mm.
pregame where he'll go not just off court, but like in the alley and he'll try to make a 3-point shot and he'll get it often and people are just amazed at his ability.
Uh-huh.
But if you compare that to a robot,
Uh-huh.
it's like the difference is if you have a robot that has multiple cameras, they will know the exact position they are on the court, the exact distance, from the backboard, elevation, conditions, and they'll be able to sink that shot far more accurately
Yeah.
than Steph
They've got
Curry.
mechanical advantages.
Yeah, it'll be like no comparison in a sense eventually. And you think that 5 robots can never beat an NBA team, but this might happen sooner than
If it's
people
open,
expect.
if we don't expect them or require them to play the same way humans do, like
Yeah.
that might not be that long. I mean, I'm much more enthusiastic about the time when a set of robots can beat an NBA team playing the way humans do, playing just the same way. You give them essentially the same physical constraints, essentially the same degree of freedom. Because I think, watching humans play basketball is beautiful, right? And watching a machine gun just like,
Yeah.
lob, sink from all the way across the court. That's like watching a backhoe dig a ditch or something like
Yeah.
that. It's super, they make these, I guess they make these sniper rifles now. So it's where you put a camera on a scope or something like that, and you pick a target that you want to hit, and then the whoever's firing the weapon, they pull the trigger, and it's really hard to shoot at something far away and hold the weapon really still, right? It kind of moves around. Well, what this thing does is it just has a camera in there and it waits for the crosshair to coincidentally cross the exact point, and then it pulls the trigger for you, right? And it's a super simple mechanism, right?
Yeah.
All it's doing is timing the trigger pull at the exact instant that you happen to be pointing in the right direction. And it's taking advantage of a couple of things that machines have really well. And they have really quick reflexes and they have a really fast ability to respond, which humans don't have. And that's very simple compared to all of the resources. A human, it's kind of a cheat, right? And yet, snipers are so much better once they have that tool.
Yeah.
So, but it's boring. It's not interesting.
Yeah.
It's much more impressive
Yeah.
to see a human being overcome all the limits of the human body and the human reflexes and stuff, and be able to do that.
Yeah. Yeah. It's thinking back on like when AI beat chess and Go and all this stuff. It's like that kind of initial shock / disappointment or humbling of the human race almost. Like where it's like unimaginable that this computer has beaten them on this like epic game, right?
Yeah.
It just seems like it's inevitable. This happens across many fields.
Everything.
Yeah, basically everything, right? And with sports and whatever, whether it's a mental type of challenge or a physical challenge, it's just one by one. It's going to be taken out, and you're going to have more and more of these moments of just humbling of the human race in a sense.
Robot ballet dancers.
Yeah.
Right.
Yeah.
that's an interesting thing to think about. We think about how, the grace and expressiveness of the human form in art and the idea that a machine could do. I mean, they will,
Yeah.
in time be
Yeah.
able to do that kind of stuff.
Yeah. Some questions from Twitter followers. Here, Rizzle says they showed a few quick clips of what the bot sees, but we didn't get too much on the brain part of Tesla bot. It was mostly hardware stuff. Was James satisfied or intrigued by anything software, vision, neural net related on the bot, or was there just not too much to show yet?
Yeah, my impression is they've done kind of a, a- essentially that there are two things going on. They're using pretty classic motion control for controlling the body, and for perception, they're taking what they have working in the cars for understanding the environment and the occupancy maps, and they've tweaked that. The robot needs, smaller voxels, and it needs, more height and more width relative to the car. And actually, if you look at the animations, you can see that they've done exactly the changes that you think. But that in a sense, those are like parameter changes that you can make to the occupancy. And this is in service. I mean, they've barely got this robot. I mean, the second generation one, they didn't really have it working yet. They showed us what they had in mechanics, and that was great. So they're clearly, going as fast as they can to get something useful, and they're starting with what they have at hand. And I think that's what we see. I'm super excited for when they move beyond classical model predictive coding for how they control the body, because I think there's tremendous potential there. And but I see no sign that they're doing that right now.
What would that look like? Would it be more like neural nets involved in control?
Yeah.
Hmm.
I mean, they're in software and in simulation, people have done end-to-end neural network systems for controlling robot bodies, and they work great. You can make of course, these are little demo type things, but there's plenty of evidence that they're going to be brilliant when we get them working, and in real robot bodies. They're already brilliant in simulated robot bodies.
Yeah. One of the things is what I got from Tesla AI Day again was kind of this confirmation of how complex building AI at scale is, like how much support and team, the infrastructure, the tooling, QA, all this stuff that you need to, data quality, compute. There's so much involved that it's not like a small outfit can compete with, these big tech companies on these super ambitious, AI projects. And it seems like Tesla has been fortunate enough to build what they've built in a way where it's actually producing something useful as actually a driving aid right now, and it's actually able to help their business model, and they're being able to build this kind of massive team. But it makes me think that there aren't that many companies who have that level of AI expertise that can build the brain of a robot to compete with Tesla. I mean, there are some right now. I think that you take the Googles or the Facebooks or some others who have large AI compute teams, et cetera. But the question is, do they have the ambition and the will and the drive to really focus on a robot or not? And what's your kind of impression on kind of the competitive landscape in terms of not just the hardware but the software side of the robot? Like, are there gonna be, you think, like more and more?
It would be great if there were. That's my first impression. I know that people really love the horse race sort of aspect of whatever's going on. But like with the robotaxi thing, as I've said a few times, like the TAM for that market is so much bigger than any organization's reasonable ability to fill it in the near term, that there's a lot of potential for lots of different people to succeed. Even after first mover advantage, it only gets you so far if you're production limited. Like, Tesla's got first mover advantage in electric cars, but how long is it going to take them to scale to building all that? To what extent does Tesla's success forestall another auto OEM's ability to even build electric cars? And the answer is like not actually all that much, right? Because there are plenty of opportunities for other things in the space, and I think the robotics is going to be the same way. Although I do think they're going to be able to scale robot production a lot faster than they scaled car production, especially if they have robots helping.
That's true. I mean, with robots, I mean, it seems like cars, you're dependent on so many suppliers also,
Mhm.
and it's like you have hundreds of parts. It's a complex process. You have batteries, all this stuff. With the robot, it just seems fundamentally so much simpler.
Mhm.
You're not relying on as many suppliers. You're building probably the actuators yourself. You have the computer. I mean, yeah, it just seems like it could scale a lot faster in some ways.
Yeah, I think it's likely to scale much faster than. I mean, simpler. Simpler is it's a interesting because it's like the pieces are easier to make and can be made in parallel, and you also have fewer pieces. That's kind of all dialed in. In a robot, you might have a lot of really small pieces involved, especially when we get down the road to get more sophisticated robots than are being anticipated right now. The part count could get pretty high, but you might be. I mean, lithography is a process that makes integrated circuits, and it can put 50 billion transistors on an integrated circuit in a small period of time because you do them all together. So processes that run in parallel like that for small devices are a lot more practical than for big devices. And I think there'll be more of those processes that are relevant to making robots than to making cars.
G. Sidhu says, is James Douma more confident about Tesla Bot after watching AI Day? Also, does he believe that Tesla Bot will be available to purchase in 5 years' time, according to Elon?
I was pretty confident about it. I don't know if I can get more confident. So yeah, probably. I mean, I was surprised at how much progress they made. I mean, in the mechanics of getting something out the door. This is, I had sort of anticipated them taking a slightly different approach, which is probably my mistake, like not thinking carefully enough. Because I think what they're doing is a good way to do it. Given the choice between that and what I was expecting them to do, I have to admit that what they're doing is a better idea than what I was thinking about. 5 years, sure. If I think Tesla certainly could make a robot in 5 years. Whether they will probably kind of depend on what opportunities they have and what they see as the risks and benefits of trying to do that. For instance, how many factories in the world might want robots, and how soon can you satisfy that demand? What are the things that you could learn by giving them to private individuals or small businesses that you wouldn't be able to learn if you didn't do that? That's part of the upside. I would not think that 5 years from now, you would have so saturated the non-retail market and be forced to go to retail to keep selling it like that. There's no chance that that's going to happen. On the other hand, it might well be the case that there's data collection merit or testing merit or just, people come up with interesting use cases for stuff when you put it in people's hands. And, 100 factories might come up with 1,000 interesting ways to use robots, and they might need 100,000 robots to do that. But you give 10,000 robots to people in the real world, and they come up with 9,000 interesting ideas for how to use them. That can all be useful too.
Yeah, I mean, it's crazy when you think about the use cases. I think, I was just thinking, it's not just a robot can possibly play tennis with me in the morning, but also before I wake up, take my dog out for a walk. My dogs all exercise and play tennis and make breakfast. I don't know. There's a lot of stuff.
It'll be the robot's dog.
Yeah. The dog will follow around the robot all day, wanting treats.
Well, the robot gives it the food, right? And gives it the treats.
It's crazy.
Yeah. What about a dog training? It's hard to train a dog. I hear that training dogs is hard. I've never tried to do it. Yeah. But I've heard from people who try to train dogs that, it takes a lot of discipline. And you know what robots have? Discipline.
And time.
And time.
And patience, yeah. um, here, Paul Moraski says, without hundreds of thousands of units collecting data, as with FSD, how does Tesla train the neural nets for the Tesla bot to get data, the data flywheel it needs for rapid improvement? Simulations? Question mark.
So there's different ways to approach doing the neural network development, and we can see different companies or approach it different ways depending on whether they have a lot of data or not, whether simulation can address their needs or not, what their use case is going to be. The robot use case is going to be different in some interesting ways. Like, I actually feel in certain respects, they don't need as much data. In some respects, they need more. The range of variety in interior environments that a robot will have to inhabit is certainly much larger than it is for cars. The range of important variables that you have to deal with. And then there's a whole extra dimension. I mean, robots really do inhabit a three-dimensional space, and cars, they kind of inhabit a 2.5-dimensional space. They really only move in 2 dimensions. And height matters, but it's less important than the other dimensions. And that is definitely not going to be true for robots. So the fact that you've got the extra dimensionality, the fact that robots they have many more degrees of freedom in how they can move through their environment. That also means you need to collect data, that's relevant to all those modalities too. So in certain respects, you need more data. My guess is from a practical standpoint, they're going to end up needing less. And a lot of that comes down to the risk of using robots in an environment. There's a certain degree of refinement that you have to get to for a system that drives a car on public roads before you can turn it loose. And this can become a big constraint on your ability to gather data. With a robot, to a first approximation, for non-dynamic movements, which like almost all movements that humans do can be reduced to non-dynamic elements. A robot can move arbitrarily slow. It's okay for a robot to stop at any point in most tasks. Like if you're feeding a machine that has a certain cycle time, well, the robot's got to move as fast as the machine does. But for a lot of tasks, the robot can just slow down, right? So you can get safety or confidence by letting the robot move more slowly. And what that's going to do is allow you to more thoroughly explore the envelope of things with a lower level of maturity in the software that you're using. And I think so as all of these techniques improve, they become more sample efficient, which means you need less data to get the same results. So with robots, I think there's a decent chance it's a sample efficiency improve. And the robot already benefits from sample efficiency improvements that we didn't have when FSD started. Like a lot of techniques that get used require a lot less data today than they did at the time. And, I don't know, it's going to be really interesting to see to what extent. My intuition is that with robots, having the robot model its environment is going to be a bigger component of success, and less have I seen every possible variation of this weird condition.
Got it. Here, Angus Yip says, Optimist use cases by stages and timeline. And then we've got a few other people. They're saying, what would be your kind of expectations or guess of what Tesla would show at AI Day 2023 for the Optimist bot? Like, what are some capabilities in 2023, maybe 2024? So let's say the next couple years, are there any kind of stages that you would expect, Tesla to reach as milestones, for the Optimist bot?
Wow, that's just kicking some ideas around.
Yeah.
So at what point is Optimus doing something useful in a Tesla factory? So that's interesting. Mm-hmm. Like I would imagine they could do that this year. If we're talking about like doing a repetitive motion, like loading part, like the one they demonstrated, loading some oddly shaped part into a machine or into a bin or transporting boxes around, like I wouldn't be surprised if they're doing that and they're able to make use of the robot. Not necessarily the case that it's the best, that it's the most economical way to achieve the task, but rather they're able to make use of the robot. Like I would not be surprised to see that in 2023. And if they were doing that next year, then you'd sort of expect them to show that to us at AI Day 2023. I would definitely expect to see significantly more graceful movement and a bigger, because they've had very little time to work on local. I mean, if you think about when they started and how long it took them, how long it would take just to get a robot built that you could start doing software on. And then you've got to do all this foundational work on the robot before you can even start working on stuff. It's kind of amazing that they've got it moving at all. So I would expect a lot more progress on that front before we see AI Day 2023. What?
Maybe some hand dexterity.
I would like to see them make the hand better. That said, there's a lot of stuff they can do with the hand, and they might decide that there are other things that are more important to work on. So I would give that maybe a 50-50 chance that we would see significant changes in the way the hand works. I feel like, understanding the environment so that you can move through it, and then getting sort of locomotion, weight distribution, your ability to move around. Factories have a lot of confined spaces that human beings work inside. So you need to be able to get a good understanding of your environment at a fine level of detail. So motion planning for a robot is pretty complicated. You got 28 degrees of freedom. A car's got like 2, right? So motion planning is significantly more complicated. And I imagine that like getting those things nailed down so that the robot can just be in an environment, move around in an environment, those are probably going to be higher priorities than like trying to move on to things that require dexterity.
Yeah. George says on Twitter, how does James rate the difficulty of advancing hand dexterity versus advancing bipedal motion on imperfect surfaces with load?
I think the hand's harder for, if we're talking about, how hard is it to do either of these two to a degree that is useful in the real world? I mean, hand dexterity, if you're picking up a bottle of water, you're picking up a pitcher, you're picking up things where, they have a handle on them, and all you have to do is close your grip on it. All of that, that's super straightforward. If we're talking about hand dexterity where, I want to write my name with a pencil, right? I don't think we're going to see that by 2023. That takes a lot of hand well, I guess the robot can hold the pencil this way and do it with its arm. Like humans, trying to write your name using your arm is hard. The robot, that's another example of robots can do it a different way. So maybe you could, but the kind of hand dexterity to write your name using your wrist and your finger muscles and that kind of stuff, that's pretty hard to do. The other thing that affects this is that there's been a lot of work on the bipedal motion over arbitrarily complicated surfaces and quadrupeds and arbitrary surfaces that they can adopt and build on. And so adopting those things, building on them and iterating, I would expect them to get that, maybe not fast, but faster than they would get, hand dexterity. I'm unaware of anybody who has made significant progress on a fully dexterous human hand that could use a pencil and draw a picture. So.
Yeah, got it. Eric Brown says, I was thinking about the reactions humans have when they're holding something and it slips from their grasp, and they reflexively attempt to catch it, often succeeding. Does James believe that AI Optimus can someday be that good?
Ooh, this is another one where the robot solves the problem a different way. Having something slip out of its hand and fall to the floor, for the processes in the robot that need to anticipate that stuff, the robot's got a week to think about it. Slowly watch the thing fall, carefully think about the set of motions. So humans do things, to a human, those kinds of motions seem really fast because our clock rate is pretty slow, and we do very complicated, very sophisticated modeling. So when you're holding something and you drop it or it bounces off a table and you have to reflexively turn and grab the thing in midair, or catch it as it's falling and whatnot. your brain is processing that in like one go. It's like one neuron. So, your sensors propagate into your head. Your head already has this model of the environment that's very sophisticated and includes many possible futures that it's considered. So now you've got this surprising future, and your brain basically flips one state thing, does one pass through a stack of neurons, and you know how to move your body. Like your body has already sort of pre-planned and stored away all of these things that it can do so that it can quickly just select one off the list and respond to it. Robots, because they run at a higher clock rate, what they're going to do is consider those well, not if they're neural networks, but planning for robots, because we're talking about planning. They have a lot of time to do this kind of stuff, so they're going to solve it a different way. That said, I think thinking about reflexes in robots versus reflexes in humans is kind of an interesting, because that is such an amazingly sophisticated and capable system in human beings.
Yeah.
But the classic reflex, of course, is a stumble reaction where you're walking along and your human stumble reaction is so fast your brain actually isn't involved, right? If you're walking and the front of your your foot moving forward is impeded, right? What that does is it fires this proprioceptive sensor in your tendon. That's the one that doctors whack on to test your reflex. And that actually sends a signal to a nerve cluster at the base of your spine that lifts your knee up and extends your knee. It lifts your hip and extends your knee. And what that does is it plants a foot in front of you so that if you're falling, the foot is in the right position to do that. And that's actually faster than a human can respond. And robots will never need that because they're just a lot faster.
Yeah, interesting. All right, so here's Bad Frenchie says, what are your best guesses on how Tesla gets a good language interface for Optimus and the cars? Partner with one of the usual suspects or roll their own?
So language models, in a sense, are getting easy because there's a lot of open source ones that you can get, and there's a lot of formulas for rolling your own or adopting something. In fact, language models, the dominant model of doing language models these days is to pick a foundation model and then fine tune it for your own needs. And it seems super likely that Tesla would grab one of those models and then fine tune it for their needs as a first cut. Also, there are so many other entities that are doing a great job and that are putting the tech out there for doing language models that I sort of suspect that Tesla wouldn't do any sort of fundamental work in that space at all, because I don't see their language needs sort of deviating far enough from what is available that they would need to roll their own.
Got it. Here, thanks for all the fish says, I'm curious what James Douma thoughts are regarding the big picture economy, society, world stuff that Elon is working toward. If all the pieces of the puzzle come together on a technological level, what are some of the societal implications he sees or hopes for? I guess the question is more like Elon saying, there's no limit to the economy, a future of abundance. Like, what are your thoughts kind of on that angle that Elon has?
It is a big step towards material abundance, right? There are so many things that get less expensive and easier to produce in volume. Like the simple material abundance, having enough food, having enough cars, having enough clothes, TVs, all the sort of material things that people want. It does feel like it's a really big step in that direction. Essentially, substantially alleviating the requirement for human labor to participate in the production of these things. The thing is, the scale, the time frame that we're talking about robotics happening on is also the same. Robots aren't the only thing that's going to happen in the next 10 years. There's all this other stuff that's going to happen, and a lot of it is super important also. And super important in the sense that it's going to substantially contribute to this vision of freeing the world from material want. It's like no matter how many robots you have, you don't get a cure for cancer just from the fact that you have robots, right? I mean, having robot lab assistants to help you mix chemicals and that kind of stuff, that's already useful. But specialized robots are better at that, and they already do it. But AlphaFold. Like that's going to move the dial on cancer research. And it won't be the only scientifically relevant new, neural network, AI, whatever development that happens in this time frame. I think many of those are going to have parallel implications for the human condition that are as big as robot. The robot one is a big one.
Yeah.
But because we're looking at this unfolding over 5 or 10 years, well, the next 5 or 10 years are going to be pretty amazing in a lot of ways.
Yeah, definitely. I can imagine a situation where you have Optimus. I don't know what year this would be, but if it's in your home, you have them do some backyard farming for you, to grow some food. But they've got time on their hands, so they could do an amazing job with farming. Like, there's like some people who do backyard farming who produce a ton of food actually, and a robot, they have all the time. They could, farm, pick out all the weeds, like make multi-levels, like they could produce a ton of food in a relatively
It's
small
interesting
backyard.
to think about we're already seeing a lot of really interesting machinery that is removing the need for human manual labor in farms, or it's like, picking strawberry. Well, I guess strawberries isn't a good example because there's been strawberry picking machines that are specialized, but there's all of these, tasks in agriculture that there hasn't been a good substitute for having a human being do it. And recently we're seeing lots of specialized robots start doing those jobs. And they may be largely automated by the time Optimus is on the scene and able to do that kind of stuff, just because there's so much economic incentive for doing that. And there are a lot of benefits to having a specialized machinery for some of those. But yeah, if you got a garden in your backyard and you want to grow 20 different kinds of things, well, having one robot that does it all. I mean, that's the point of a humanoid robot, right?
Yeah.
It's on the one hand, the fact that it's not specialized is both its strength and its weakness, right? The fact that it's not specialized means you can use it for lots of things. Because specialty is a two-edged sword, right? You're really good at the thing you're specialized for, and you're really terrible at everything else, right?
Yeah. I kind of think my mind goes to like, what would humans do to be productive and useful around the house if they had like 100 hours a day, like just free time to do whatever?
1,000,
yeah. Like, that's probably what, the robot might be doing in some ways. Because like just cleaning the house, it's not going to take that long,
Depends on how clean you like your house, I guess.
That's true. Yeah, there's some
Did
people.
you ever, Isaac Asimov, he wrote these novels like back in the 60s where he imagined a world of, a world, he had space travel and stuff. So he imagined many worlds where there were lots and lots of robots. And he imagined these societies where there were so many robots, there were so many more robots than people that like people didn't interact with each other anymore. And it was rare for them to do that kind of stuff. And, individual humans would have these vast, sprawling estates, with all of this kind of ridiculous overhead that was associated with just like maintaining a single human, because all of their quirky little wants and needs were suddenly able to be satisfied because, like unlimited material wealth.
That's true.
It's I think even now, thinking back about those stories, that he explores a lot of interesting ideas. And maybe I should go back and read those and think about that stuff again.
Yeah, that's fascinating. All right, so Dojo, from what Tesla showed at AI Day, like how far are they from Dojo contributing meaningfully to their training effort? At least, let's say, 10% of the compute for what they're doing.
That's funny. I think, yeah. So they've already demonstrated a couple of interesting capabilities, like at the tile level. We don't know. I mean, they say they've got a rack coming up, and that they're going to have a whole dojo in Q1, right? Yeah. I would expect that they can get useful work out of it next year. So this is kind of an interesting moving target thing too. There's a lot of difference between having all the infrastructure to be able to run heterogeneous jobs and keep the machine busy all the time, and easily adapt to new jobs or easily adapt the jobs that you have running on it to be able to drop code on. They're clearly working on the software infrastructure that they need to be able to, they demonstrated stable diffusion running, which stable diffusion running on it was, just as a slight digression, is an interesting example. One of the reasons to pick stable diffusion and run it on is not just because you get some, meme-worthy pictures coming out of it, but also because stable diffusion's only been out for a few weeks at the point that they do this. So it wouldn't have been possible to do that demo if they couldn't quickly adapt a generic PyTorch model to. And I think that's one of the reasons they picked it, is because, people who are paying attention are like, yeah, you didn't have a guy go in the back room and work on that for 2 months and then lie about being able to adapt it. You really had to be able to do it in a couple of weeks. So they're working on that. It looks like to me like they're making progress. I mean, the compiler stuff that they're talking about seems like exactly the technology that they need to be able to make good use of it at scale. They clearly have enough primitives working that they can run, some amount of the workloads that they have right now. I would think the interesting test would be like, at what point can they run auto labeler on it? And off the top of my head, I can't think of a good reason why they wouldn't be able to do it next year unless they're running into a lot of problems on the hardware platform. But there is another thing, because they're building this thing themselves. A lot of issues are sort of, for lack of a better term, that clock frequency specific, right? So, because they're building Dojo from scratch, they can just turn the clock speed down a little and get it working. And then gradually, as they refine it, as they sort out the interconnect problems, we see that they've got the D1 die working, right, well enough to run stuff. And they've got tiles working well enough to solve problems at the tile level. We don't know about the tile interconnect. Like, we haven't seen them basically demonstrate to us stuff that takes multiple tiles. So, and that, I think that tile-to-tile interface, like that's going to be challenging. And then extending the tile-to-tile interface across cabinets, that's also going to be challenging. At what point will they solve that? Do they have some really big problems in that space? We haven't seen proof that they've got it solved.
Yeah.
That said, I'd be pretty surprised if they weren't making enough progress on it to be able to do useful things with the cabinet in 2023.
Yeah, interesting. Here, Mickey Ficky says, what does James think about a way to monetize Dojo? Is it really feasible, and what will the ROI, return on investment, be, or will it be worth it? So another kind of angle or different kind of take on this is, as I see Tesla, it seems like, they're actually getting things to work with Dojo, investing more. They're seeing this as a legit platform for them to run their future training on. It just hit me at AI Day, where I'm like, oh, it's more about Tesla taking their future AI taking it into their own into their own hands. They're basically owning the destiny of their future AI, because they won't have to borrow, let's say, compute from another service, or they don't have to be reliant on another company's architecture, or they're not susceptible also to competition who can undercut them significantly in terms of compute power via making their own chips that are, more efficient, et cetera. Tesla's saying, hey, we're not going to risk any of that, being too dependent or too susceptible, too vulnerable to others. We're going to create our own chips, our own structure. To me, the Dojo as a service, that to me is like, it's not the priority. The priority is securing the future, of Tesla AI, to get as much training compute as possible at the lowest price that's actually custom designed for what they're doing. It's almost like this, it's Elon playing like 3D chess in a way, like, a few moves ahead of anyone else. And to me, it's like fascinating that they're investing so much effort and money and right now, but it makes so much sense. It reminds me a little bit of the whole put the FSD computer in all the Model 3s, early on, because we're going to need that. And just seems like Dojo is another one of those, like, big moves by Elon
Hmm.
to kind of future-proof Tesla
Yeah, it
AI.
does feel very
Yeah,
similar to
it's
that.
so interesting. What's your any thoughts on that?
I think on the Dojo thing, I've described Dojo, fundamentally as Tesla investing in economical compute in the future. They've got a very, their roadmap is very dependent on the amount of compute that they can get, and almost to the point where you can't have too much. When you get to the point where you're spending $1 billion a month on compute, $10 billion a month on compute, like you want to be getting the most cost, like you can afford to spend money to bring the cost of that stuff down. And it'll take time to really bring it down. If you look at the industry that is building systems that you can buy and put in your warehouse and run data on is not taking radical risks for the most part. The leaders are still basically incrementally iterating on a platform which is not good at neural networks, and there doesn't seem to be a lot of movement by big players with deep pockets to like step off that train, right, and do something radically different. So Tesla's, in a sense, they're if you think of them as trying to compete against, in the space for selling compute to other people, they're taking advantage of an opportunity. But another way of looking at it is just like they're they have a lot of things that are vulnerable to whether or not these other companies perform. So yeah, they're taking control of their own destiny by developing this machine themselves. I'm kind of biased on this. Like for a long time before Tesla announced that they were building Dojo, to my acquaintances in the space, I was complaining that nobody was doing a Dojo kind of thing. Like there's so much potential to do better than what industry is doing right now. And yet, when I look at the incentive structure for the players in the industry right now, they already own this space and they don't want to disrupt it. They don't want to, initiate the technology that causes them to lose all the business and some startup to get it or some competitor to get it. So they're all moving very carefully as they move forward. And that's robbing the rest of us, the rest of industry, of the really powerful platforms that we could have in 5 years or in 10 years. So Tesla went and did that. Once again, I'm really happy that they're doing it. I think it's not that there's nobody, who's trying other things. There are a number of notable companies out there trying really different stuff, but they seem much more focused on making money near term, returning something to their investors than, making the world a better place, scaling as fast as they can, taking big risks.
Mm-hmm. Yeah, got it. Elon mentioned at the beginning of AI Day how he thinks Tesla can make I forget the exact wording, but a significant or a contribution toward AGI. What's your kind of take? Do you think that's premature for Elon to think that Tesla will have a significant role, or do you understand his perspective?
You have to look at the way he framed it, I would say.
Yeah. Well, how would you interpret that?
Like if you were working directly on AGI today, you would be looking at, Jan LeCun recently trotted out a white paper, I don't know if research paper, it's in open review, where he's basically saying, this is the set of all things that we might want to try doing to get an AGI working, right? There's this sort of research component. I think, as I understand what Elon was saying, it was basically, you need a lot of data, you need scale. We're scaling really fast. We're going to have a lot of data. There's a decent chance that that AGI ends up being an emergent property of being able to get to big scale with big models. And if that's true, they will end up playing a role at some point because they'll be one of the players that has the scale and has the data to be able to like move the needle on, sort of getting over that phase change threshold where you start having, AGI is an interesting topic because it gets defined a lot of different ways, and you can think of it a lot of different ways. So it's hard to make accurate, narrow statements about it.
Yeah.
I think that, that what the way Elon frames it, and I agree with his statement. I would say, Tesla's not working on AGI.
Yeah.
They may end up being a player because a lot of these other approaches, a lot of these things people are working on, they may converge as we move forward. Like AGI may be a convergence of a bunch of different things. And if you're a big player on one of the important things, then yeah, you'll be playing a role in AGI.
Yeah. What do you think about this angle where you could, someone might be able to argue that Tesla, by being the so-called, arguably the leader in real world, of this physical world AI, that they're just gathering the trajectory of how fast their data is growing is just growing faster than just any other big AI player that's more focused on online. Because like online, you have like, you're combing through texts and whatever images, but I guess you do some videos, but they're more like talking head videos, or they're not like it. You don't get the resolution or the 3D type of data that Tesla is getting. If you project this 5 or 10 years in the future, if Tesla continues to just radically gather more data at a faster pace, let's say, or their rate of improvement of how much they're gathering data just increases so fast as they dive deeper into this. Is there a scenario where Tesla actually just eventually outpaces other big AI players because of just the sheer amount of data combined with all of the other, training, everything that they're doing?
So Tesla's getting a different kind of data than other players are, and so that's a differentiator for them. Also, Tesla's strength is not like having lots of data. It's being able to get data to get. I think I've said before, the FSD fleet is not a recording engine. It's a search engine, right? You ask the FSD fleet for a bunch of stuff, and it samples the world and finds those things and sends them back to you. Because the world has got so much data about so many things. Trying to record everything and having this giant repository where when you have a problem, you have to go digging through this repository to find that is in many ways less effective than letting the world continue to be the data repository it already is, and essentially having this mechanism that goes out and gathers the data you need. That's how the data engine works. The data engine, they had the parked car video on this thing. They had a clip where there was a car parked, and it was parked in a place where normally, in fact, when I first saw the clip, I thought the car was stopped at an intersection, but it was actually parked. And the problem they were trying to fix is they need a bunch of examples of weird intersections or weird places to park a car where it looks like it stopped at an intersection, right? How obscure is that data? Like, how do you do that? But, they gathered 13,900 clips like that of examples that they were able to sort of label and dump into the system. That's the search engine at work. Search the world, find these things. I need them. Send them back to me. 2 weeks later, 2 weeks. You've got this data. You filter it. You run it through the auto labeler now. You don't even have to send it to your army of labelers. It runs through the auto labeler. You put it in a thing and your problem is solved, right? The data engine is iterating on problems that you find, asking the real world for the data and bringing it in. So Tesla's data, Tesla's differentiator is they're sampling the real world for data in real time. Now, in some sense, other entities have this, Google can change a user interface element and see millions of people interacting with that user interface element and sample the world by essentially making a change. They have this interface to the world, which is their website, and they can gather lots of data. Like, they can change the way that the rating system in YouTube works. And they have so many users out there that they can gather a lot of data on how that works really quickly. So it's not completely unprecedented for other entities to have this. But comparing it to like all the data that Google has gathered on YouTube, right? Or all the tweets that Twitter has saved, which is in this giant repository, is a little bit different, right? Tesla's got an ability to say, if I interact with the world this way, statistically, how does the world respond back? They can change the behavior of the vehicles a little bit and then gather a lot of data on how that changes. And that's, it's a kind of categorically different kind of data that they're able to gather in volume whenever they need it. And of course, they've got a big storage farm and they can store a bunch of stuff too. But I think a point that came up on AI Day was, I forget who it was that made this comment, that that the data that Tesla uses, that they have for training the networks, it actually is fairly ephemeral because they're constantly feeding new data in. And then they're constantly taking out stuff that isn't as useful. So, so they might label a clip, stick it in to solve a problem and add it to the system. And maybe that clip only lives in their data warehouse for like 6 months or a year, because as they continue to refine the thing, they discover that, that of the data that they collected, 3 months ago, they 25% of it, they no longer leave. So it gradually sort of, it's not an ever growing collection of data.
Yeah.
It's a precisely sampled cross-section of the world the way that it is today, according to our best understanding of what we need to train the network.
Makes sense. I've got a bunch of more questions, especially with occupancy network. Seems like people are really interested in that compared to LiDAR, what's going on with Nerfs. But we'll go ahead and cover that in our more technical deep dive tomorrow. I'll go ahead and wrap the video up here. Go ahead, I'll link to James's Twitter account and check out the next few videos on this channel because they'll be fun with the technical details about AI Day. We're going to go through some different slides that James has prepared and kind of, I would say dumb them down, but simplify them, trying to help the layperson understand what Tesla's doing with AI Day. Kind of like AI Day for dummies, but
AI Day for non-specialists.
Yeah, non-specialists. Right? Yeah, exactly.
Yeah. Well, one of the interesting things, like you look at the slides, people who aren't in the individual bins aren't going to know what the other bins are, by and large.
Yeah. Sounds good.